Good morning, everyone. Still snowing for those keeping track outside of Waterloo. Snow, snow. So today we're going to continue what we were talking about last time with text representations for document clustering analysis and classification, but basically dealing with text. We're almost filling in a completely blue screen. People have taken a goal to simply color it blue. This has not happened before. It's very exciting. There, you've completed your task. Any questions? People don't like snow. Oh, Alex tells us that it's 30 degrees in Argentina. Thank you very much. That's great. Now we feel nice. 30. I mean, that's almost too hot. You don't want to complain, you know. But all right. So, anybody have any thoughts or questions or worries about yesterday's topic? We were talking about representation of text. Like we said, there are lots of other things to talk about in this field. So we're gonna kind of go through all the fundamentals, and then, like we said, later in the course, we'll talk about some things that have been happening recently. But I'll show you some examples of where it's been going in today's lecture as well. So we're talking about representing text as frequency counts of words. So how often does this word show up in a document? And that gives us a number. So what we really need is we need to get some kind of number to turn that. Oh, I had it in two places. That's why. Oh, no. Okay. This is later. Yeah. So we're going to get to that in a second. That's why. This slide looks similar to this slide or something. So we had this. So we're counting these, just how often a word shows up in every document. We defined a predefined vocabulary of words. And that gives us a numerical vector per document, right? So we end up getting this table. Once we've got our data represented as a bunch of numbers, we feel safe and happy, and all our algorithms can work. But text is different than other numerical data. So maybe there can be different ways to measure like similarity and distances between points, which is going to be useful in a lot of situations. And so, I mean, you can always use the Euclidean distance between points, which is just, right, the, square root of the square of the differences. I'm trying to put my pointer on. Great. But another one that's very useful for text is basically the angle or the cosine distance. So people use different forms of this. Essentially, the dot product itself, right? I did figure out how to use the pen on PowerPoint yesterday. So if I have the pen turned on, sorry, we'll have blue. We have the dot product, right? And so the dot product includes this kind of idea of the scale of the two vectors as well as the angle between them, right? And so you can get the cosine out of it, or you can get the angle out of it. So that's going to be very useful, actually, because what we want to be able to do is talk about the distance between two vectors in this meaningful space. Remember, actually, one of the questions yesterday from someone was like, what is the direction, if we're talking about them as vectors, and magnitude, fine, somehow like importance, but what does the direction in the vector mean? And we really want the direction to encode meaningful information. So I've got my window of useful tabs today that we'll look at. So if you remember from high school math, right, when you've got your two vectors in one direction and you want to get the angle between them, you can use the dot product, right? So when we talk about the magnitude of the combined vector, so what is the dot product of the two vectors, right? Remember, the space could be, in our case now, it's going to have as many dimensions as there are words, right? So we have a vocabulary maybe of 10,000 words. So 10,000 dimensional vector with little numbers on some of them saying how often you saw a word in a document, and all the other ones are 0, right? So it's a really weird vector in this space. But every word has its own direction, right? And so, you know, hot has a direction and cold has a direction. And if you took the difference, if you take the dot product between the words hot and cold, you'll get another vector pointing in a different direction, middle-wise, across different dimensions, if you can think about it, right? And have a different magnitude, different direction, but that's what dot product would give you. And you would expect or hope that if your encoding is meaningful, then the magnitude of, the direction of this vector for hot and cold would give you something that is like medium or lukewarm or normal, you know. And so it would make sense if your encoding is meaningful that these directions actually correspond to some kind of meaning in text. So that's a tall order, and it's not really something you'd reasonably expect to happen naturally. But people have found a way to do that. So it's actually very exciting. Right, but that idea of dot product and angles is what is being used there. So the only question is how to make such an encoding, how to come up with a dimension, like a space for a document and for text that such that will be true. So we're not quite there yet, but so using this idea of counting terms in a document, you can talk about the term frequency. So how often does this term, so any word like hot or cold or dog or cat or nuclear, how often does it occur in all the documents? And so there's a disadvantage to having this because if a term shows up in all the documents, like the or car or soccer ball or something like that, or ball, right? If you're looking at sports articles like we were talking about yesterday, ball is not very helpful because it's probably in all the articles, right? So that's not going to help you distinguish which article is about soccer versus basketball, right? The word ball is not going to be very useful. And it will have a high term frequency in all the documents. So you could also talk about the document frequency. So how many documents does a particular word show up in, just to tell you whether that word is useful or not. Right? And so if a word obviously shows up in very few documents, it's like equivalence, right? The word equivalence probably doesn't show up in many, news articles. If we're talking about a news article site, all the documents with the word equivalence in them would be, less, it'd be more discriminating because it would help you distinguish those documents that have that word versus the ones that don't, right? And I guess if you're talking about sports ones, the sports articles that have the word bat in them, that's pretty distinguishing because there's only like 2 sports that have bats in them, right? Cricket and baseball, right? And so you could split all the sports articles into the ones that have bats and the ones that don't, right? Whereas ball would not be very useful because bat has a lower document frequency in sports articles, but I would assume that ball would have a high document frequency. If that makes sense, people. Okay, so then we can combine some of these ideas together then and start giving us some really useful scoring methods that we'll use for terms. So we combine both these together. We take the term frequency for a word, right? How often does that word show up in the document? And then, right, the TF tells you that I is for which word it is, right? Of the word, the term in the vocabulary. right? So it's literally the word bat or ball or cat or dog. And then we'll talk about its document frequency across all the its frequency across all the documents. I'm trying to see my notes here. Yeah, that icon got moved. So the index is on the document frequency because we can't index this division. I didn't know what that meant, so my I got outside the bracket there. So this score takes the inverse document frequency, right? So we take the size of all of the words and give us this this score based on it's not just frequency in an individual word, but also how rare it is in all the documents, right? So you want a word that shows up. It's meaningful in this current document, but it's something that's rare in all the other documents. So if you have something that has a high TF and a low DF, is why we call this a TF-IDF score, then it's going to be really useful because it's not a word that's rare in the documents you're trying to classify, but it's rare in all the other ones. So like I was saying, bat for sports articles would have a high TF and a low DF. So we usually would want to normalize this if all your documents are kind of different lengths, like there really are news articles or something. Then you want to make it so that this score is meaningful to the size of the document. So a short document, you don't want it to have a higher TF-IDF score just because the document's long. So you normalize it over the scores of all the other words in the document. And J would be over, well, all words. It would include itself. But it would give you one that's they're scaled sort of equally, so they're more comparable, right? And then when you're talking about this log one is really just to help you scale the differences, right? Because some words show up very rarely, and some might show up hundreds of times in your database. And so the difference between them could become very large given the ways these are scaled. So when you put logs on them, you know, things become less extreme. So they'll really be very large numbers will be collapsed down to something more reasonable. So you really want to scale it so that very large scores aren't necessarily 1,000 times more important, but if it's 1,000 times more important, it's at least twice as important to look at for classification. So log kind of gives you that scale. Since I got my I wrong on the previous document here, I'm a little worried about all the indices here. So we should check all these indices, right? Because these should at least match. I think they should be J underneath, because you're talking about all the other terms and their score and normalizing over all of them. But I'd love to look it up. But this is very commonly used metric, this TF-IDF, because it gives us that usefulness essentially for classification or clustering documents, right? To say that these words are important to some documents, but not in all of them, right? And I guess, yeah, my slide here was already saying some of that. So at least the calculation, now we're not saying that the words in the documents are independent and uncorrelated, but the scoring we're doing assumes that, right? So we're just going to take each term separately, each word, and assume that it's got its own independent count, and then give us a scoring based on them being separate. Right, so it's not kind of a true representation because it ignores all these dependencies and correlations, right? And you have a bunch of words in a document, right, right beside each other. You know, whatever it is you're saying, they are not independent, right? This word is related to the words around it and all that. TF-IDF completely ignores all this, and so that's a drawback. But for a quick and dirty statistic you can use, it's actually quite powerful, especially if you're looking at document level classification and all of that, right? Because you're really comparing the entire document taken as a bag of words rather than the location. Yes?
I just have a quick question. How can we say that the terms are independent and correlated as a pro, but then we say that, well, dependencies matters? So we're kind of saying, like, on one side, yes, it's a pro to be independent and correlated, but then on the drawback, well, we actually need to be to account for dependencies and correlations.
Yeah, that's why I was hesitating when I put it in there. I was like, I guess, I mean, it's a benefit. I guess it's because of speed. So I like for computation of it, of the scoring, it makes it faster to compute. It's clear to understand, but it's not true, right? So it's not like a benefit in the sense that we're trying to enforce that on the model, but it makes it fast to compute and simple to understand, right? So it's useful for that. But yeah, but that's why all these drawbacks are basically like, since this is false, it's ignoring a lot of the structure. But you can use multiple of these things together. Yeah, no, good question. Yeah, okay, so someone actually a question about, okay, maybe people have resolved it. Right, the frequency of a term in a document versus the number of documents the term is in, right? So they're two completely different counts, but they give you different measures of frequency. Right? So how many times does the word ball show up in this article you're reading, and how many times does how many articles does the word ball show up in, right? They're two separate statistics. And so you're trying to combine them together. There's a whole bunch of other metrics that are used to represent that. So using these kind of counts and documents that would have different kind of benefits depending what you're looking for. So what are we doing here? Yeah, so one way to do, I guess, clustering, we'll have some examples later, or classification would be to just say, you know, are these points, like if we were thinking about our k-nearest neighbor method, right, we could use these, I guess it would work better for k-means, which we haven't talked about yet, so that's why a lot of these are used very well for clustering, that if you have these distances, these, I guess, scores for every word, you can use it to tell you whether it's important or not, and try to build a classifier using just those scores, saying these documents are similar because all their words have this similar score.